All right, you are ready. You are ready for the most important calculations of the entire course. That's right, I said it. That's right, I said it. Cheers. We're talking about Willis. What I'm talking about is, as I said earlier, the mole is the most important concept. This is my opinion, although I'm sure a lot of people would probably agree with me who know chemistry. Most important concepts of mole for Chem 1, the most important calculations are mole calculations for Chem 1. We're going to need those for stoichiometry. We're going to need those for all kinds of things down the future in the line of chemistry later on. Right now, we're doing it. We're doing the most important calculations. Oh, I didn't say the only ones. I didn't even say the hardest. These are by far not the hardest calculations, but they're important calculations. So let's dive in and do the most important calculations of the course right here, right now. Okay, mole calculations. What I'm going to do, watch carefully, is on the board, got the word mole. We have the word gram. And over here, I'm going to put several words. One is atoms, molecules, formula units. I'll abbreviate that FU. Don't get offended, for crying out loud. Some of you go, oh my God, I can't believe you did that. It's formula units is what it stands for, people, okay? So formula unit, remember from the last video, a formula unit is that's one metal, non-metal. It's like an ionic compound. So salt, sodium chloride, NaCl. If you wanted to get the mass of that, that's a formula unit, as opposed to a molecule, which is two non-metals like water. Okay. I mean, sometimes people just go, yeah, they're both molecules. Not really, but okay. So here, and we'll see why I put three words over here: atoms, molecules, formula units. A little less than, make it plural. I'll put particles here too. Particles. Okay. So this is how we're going to convert. You can convert things based upon this layout. What do you mean? If I have grams and I need to figure out moles, I can go ahead and do that because grams has an arrow connecting to moles. If I have moles, I can convert to grams because moles has an arrow connecting to grams. If I have moles, I can calculate how many atoms that is, or how many molecules that would be, or how many particles that would be, how many formula units that would be, because it has an arrow connected to it. If I have the amount of atoms, I can go right to moles, but you can't. 9. You cannot go from atoms directly to grams. You can't do that. You cannot have 32.9 grams of water and go directly to how many molecules that is. Can't do that. We have to go through the mole. The mole is central. It's key. Important. You have to go through the mole when converting grams to atoms, atoms to grams, grams to moles, moles to grams, moles to molecules, The key central part is the mole. So also what I'm going to do is I'm going to put some things up here that are important that we need to know. 1. I'm going to put a 1, the number 1 above the mole. You'll see why. Grams, I'm going to put PT. PT. Brother of ET. Anyone? Yeah, ET. Phone home. ET, phone home. PT stands for periodic table. So periodic table, 1. Over here, avocado and his number, 6.02 times 10 to the 23rd. We will see why I put these above each one in a minute. So I'll put these in parentheses. All right, so you're going to need these, that's why. Okay, what would be a conversion that we would have to do? Now, these conversions, this is not stoichiometry. I know that's a scary word if you remember your chemistry. Stoichiometry we get into next week. We talk about, and that has to do with balanced chemical reactions and mole relationships, mole ratios, and blah, blah, blah. This is not stoichiometry. These are relatively simple conversions, but they're important. Important. Simple but important. Okay, how do I do these? What kind of an example problem would I have? Here's one. Let's say that you have 36 grams of water is how many moles of water? Moles of H2O. I mean, I don't have a worksheet for these. I'm going to make them up. And when it comes to stoichiometry, I got all kinds of worksheets I give you, and you just go over them. You'll have them in front of you. But this one, I'm just going to make these up. You can do it. You can do it. Stick with me. So here's a question. 36 grams of water is how many moles of water? Or no, it's how many moles are there in 36 grams of water? This is a conversion. Remember, we learned dimensional analysis. Let's start applying it. So let's dive into our dimensional analysis. If you remember, you write down what you know you have. So I have 36 grams of water. So I write down 36 grams of H2O. Multiply, divide. All right, okay. Remember what you did in your dimensional analysis? You take grams of water, and if that's the unit that you have, you make sure that goes in the bottom so it cancels out. Now, grams to what? Oh, right here. This is where this comes in. The mole is key. The mole is central. Do you ever fly across the United States? Have you ever flown from Boston to LA or Boston, San Francisco, Boston, Seattle? A lot of times you can get direct flights. You can. So that analogy is not going to quite work here, but most of the time you got to stop in Chicago. It's like Chicago's like the hub of the universe for the United States. So Chicago is where you got to fly to, and then you fly out of Chicago anywhere you want. So Boston to Chicago, and then wherever you want to go. So Boston to Chicago, Chicago to Seattle, Chicago. You got to go through Chicago. The mole is like Chicago. Okay? Grams, Boston, Chicago, Seattle. Never been to Seattle. I'm in San Diego, though. I'm going to San Diego. San Diego's beautiful. Nice. Same temperature all year round. Low in January of 68 average. High in July of 78 average. Pretty sweet. Okay, so we're going to San Diego here, people. You pick your city. I'll pick mine, okay? America. I can do whatever American city I want. So, Boston, Chicago, San Diego. You have to go through Chicago. So what we're going to do, this is a one-step flight. We're going from grams to moles. We're trying to figure out moles. So I'm going to put moles here. You have to go through the mole. You have to go through the mole. So moles is going to go on top. Remember, I've already said it several times, the most important thing you will learn, in my humble opinion, in Chemistry 1 is right here. Gram to mole conversions. They're not hard. We've done what we need to do previously to get this correct. We know what the mole is, and we know how to get masses. So what you do is this. 1 goes next to the mole. Always, always, always. That's why I put a 1 here. See, that's why the 1's there. 1 goes next to the mole. So I put a 1 here. Where I see mole, I put a 1. Easy. 1 always goes next to the mole. Until next week. I know it's chemistry, people. It's frustrating. But for this week, 1 goes next to the mole. Whenever you do a mole to gram conversion, you always put a 1 there. Add up the mass of a mole of water. Remember earlier we did masses. We already know the mass of water is 18. We've done it. Okay, 2 hydrogens, that's 2, and 16 is 18. So 18 is the mass. So why did I put PT here above grams? Because when you have grams, you're going to need the periodic table to get that mass. Unless you've got to memorize, which would be great, but most of you don't. So use your periodic table when you're in grams to get the mass of the thing that you have next to grams. So this says, and this should make sense, we talked about how this works. 1 mole of water is 18 grams, because it's a mole, of water. All right, is it all coming together now? Sweet. All right, so now grams of water cancels. That leaves me with moles of water. And that's exactly what the question's asking me. Do the math. All right, so do the math. 36 times 1 divided by 18. Dos. that would be 2. Oh, let's review significant figures here. This is considered to be, a factor label method. We only look at the number out in front for sig figs. So there's 2. So how should I write that? Should it just be 2? Have that at 0.0. 2.0 gives me 2 significant figures in that answer. So 2.0 moles of water is the amount of water that I would have with 36 grams. Okay, that wasn't that bad, right? All right, make up another one. Let's see. Okay. If you have 2.7 times 10 to the 25th molecules of carbon dioxide, how many moles would this be? How many moles would you have? How many moles would, question mark, short for how many moles would we have? Okay, factor label. This time, you're at molecules. It's over here. Remember, that's why I put so many words over here, because it could be atoms, molecules, formula, units, or particles. So how many molecules? So you're here. You're in San Diego. You're in San Diego, people. Where do you want to fly to? You want to fly to how many moles? You're flying to Chicago. You're going San Diego to Chicago. Say it's a one-step flight here. That's it. So let's go ahead and do this. Write down what we know we have. So 2.7 times 10 to the 25th molecules of what? Carbon dioxide. Multiply, divide. So molecules of carbon dioxide goes on the bottom, because that's what I have on top. Now that means molecules here, I have to go to the mole. You have to go here. You have to put moles. That's a molecule. That's a C on the bottom. That's not moles. That's molecules, and that's moles. Moles of CO2. Okay, so molecules of CO2, 2 moles of CO2. That goes on top. What goes next to the mole? Every time. Right there. 1. 1 molecules. I need a number here. What should I put here? Molecules. Avocado. All right, put his number there, because that's what you're going to need. When you're here in San Diego, you will always, always, always use that number. That goes here. 6.02 times 10 to the 23rd. I have got this set up to get my answer. And so molecules to moles, 1 step. I go ahead and do the math. This is going to be much easier if you have a scientific calculator. If you don't, you can go ahead and divide it. You got to remember your division rules for exponents. But I would just get one of these bad boys. If you have a cell phone, you have a scientific calculator on there, so get one. So let's see, 2.7. I would go second function EE 25 divided. Some of you don't know how to do this, or you forget how to do this. Let me show you. So what I'm going to do is divide by 6.02 times 10 to the 23rd. So divide 6.02. I always hit, let me get this lined up here, second function, and I go with, there's an EE, that means exponent. Second function, EE exponent, so I hit that button, and it gives me a little flashing cursor up here, and I can put whatever I want there. And I want to put 23. So 23, 6.02 times 10 to the 23, and then go ahead and hit enter. Boop. And I get 44.9. Rounding this off, it comes out to be 44.9. So 44.9 moles. 44.9 moles of my carbon dioxide. All right. Okay. All right. Okay. All right. Okay. All right. Okay. All right, yeah, that makes sense. I'm looking at the numbers in myself. I can go through these. I've done this so many times. I know how to work numbers in my head. Work magic numbers. That's smaller than that, so to move the decimal point over 1, like to move this over would be like 24, and then 24 divided by this is a 10 factor. So this should be in the 10th, not more than 100, which makes some sense. Okay, so let's do another problem. Do it now. Do it now. Predator was on the other night. It was awesome. I watched it. I watch Predator. Get to the chopper. Kill me, I'm yum, kill me. Great movie. Actually, I had the wife watching the movie. She's never watched it before. It's pretty sweet. But she didn't know one of the lines. If it bleeds, we can kill it. Sweet. Let's do another problem. Okay, here we go. Given 5.0. Oh, I didn't check the significant digits on the last one, making sure it was in the right amount. I forgot what I used. Oh, I had 2.7, so it should have been 2 in the answer. Oh, it should have been 2 in the answer, right? I got 2.7, if I remember right. And then I came out with 44.8. So I should have rounded that. If some of you might have been paying attention to this with the correct amount of significant digits, I was just thinking about Predator and get to the chopper. So it should have been 44.8, should have been 45. So we should have recorded that with 45, 2 significant digits. Okay, so given 5.0 times 10 to the 30th particles of calcium hydroxide, how many grams would this be? So given 5.0 times 10 to the 30th particles of calcium hydroxide, how many grams would this be? There's a lot of chemistry in here that we've done right here. There's a lot of chemistry. Chemistry is building up for us here. Okay, keep up. One, actually I use the word particles. That kind of covers you. Particles covers you, whether or not you're talking about molecules or ionic compounds, because remember molecules are actually two nonmetals, and a formula unit is your metal and nonmetal. I say particles, just like covers both. Pretty good. So given 5.0 times 10 to the 30 particles of calcium hydroxide, there's some naming there and formula writing. Calcium, that's polyatomic ion hydroxide, and we have 2 of them because this is a -1 charge, and calcium's a +2, so they don't match, so we got to crisscross those. Crisscross. Calcium hydroxide. How many grams would this be? Okay, where are we? What city are we in? Particles. We're in San Diego. Where do we want to fly to?